Hello, today we're going to look at a hydrocarbon called alkanes. So we're going to look at alkanes, which is under the organic chemistry. So before we go to that, we just do an introduction on alkanes. We talk about how to name alkanes. After that, also look at how to draw structure, molecular structure, and the skeletal structure of alkanes. After that, we'll touch part of properties or reactions that alkanes do undergo. Yeah, so the first thing we'll do is to understand what hydrocarbons are. What hydrocarbons are? What are hydrocarbons? So these are organic compounds which contains carbon and hydrogen atoms only. Whenever you see a compound with carbon and hydrogen atoms only, just know that that is a hydrocarbon. Examples are alkanes, alkenes, alkynes, cycloalkanes, cycloalkenes, they go on and forth. Okay. After understanding what hydrocarbons are, you also need to understand what a homologous series is. A homologous series. So this is a group of organic compounds with similar chemical and physical properties only, but different in smaller units. What kind of units? For example, a compound is having a difference, just a difference of this. There's a difference of this, and we're going to say there's a difference in units. There's a difference in units, and that's what we call homologous series. After understanding what that is, we can define what a structure formula is. A structure formula in organic chemistry, it shows the lone pair in the atoms bonded. Okay? It shows the lone pair in the atoms bonded. For example, if you have this, this is a structure formula or Kekule structure. That is the other name. In case a different name is used, the one you're not familiar with, you just know that that is a structure formula. After knowing what a structure formula is what we call a skeletal formula. Is what we call a skeletal formula. So a skeletal formula can, for example, if you're having this structure of ethane, you're having a structure ethane. This is a structure formula, but how will be the skeletal formula? It will be like this, or like this. So where do you find the carbon in this skeletal structure? It is at the end, in the corners. This. Okay, there's carbon here, there's carbon here. There are 3 hydrogens here. So how can you define skeletal structure? It is a structure showing only carbon atoms and other atoms other than hydrogen. So how does it show carbon? The end that you see, any corner that you see or end, there is carbon there. So it is showing carbon, and it will show other elements apart from hydrogen. Okay. The last thing we'll talk about is under definitions, it is the functional group. Functional group. What is a functional group? It is a reactive part of an organic molecule. A reactive part of an organic molecule. So each hydrocarbon has a functional group. Each hydrocarbon has a functional group. For example, alkanes, they have a functional group. They are saturated and they have single bonds. Alkenes, they have a double bond, unsaturated. Alkynes, they have triple bonds. Okay? Alcohol, they have OH, those are functional groups. Carboxylic acids have COOH, those are functional groups. We'll come to that. So now we'll look at alkanes in particular. So we'll look at alkanes in particular now. How do we draw the structure? How do we name alkanes? What about them? Okay, so the first thing we'll look at it is the general formula for alkanes. And the general formula for alkanes is CnH2n plus 2. What is the meaning of this N? The N simply means the number of carbon atoms in that alkane. N is equals to the number of carbon atoms. But how do you know the number of carbon atoms? You're going to know from the suffix you're going to be given. Okay? For example, whenever you hear something, whenever you have meth, just know that there is one carbon. Whenever you see F, it is 2 carbons. Prop, 3 carbons. Bute, 4 carbons. Pent, 5 carbons. After pent, we'll come to hex, 6 carbons. Hept, 7 carbons. Oct, 8 carbons. Non, 9 carbons. Dec, 10 carbons. Undec, 11 carbons. Dec, 12 carbons. They go on and forth. Can go even up to 30. Okay? So that will help you to know the number of carbon atoms in an organic compound you're given. For example, alkanes. So now, since we have these suffix, what will be the prefix? All alkanes end with, they all end with A, N, E. They all end with A, N, E. This is the prefix for all alkanes. All alkanes have a prefix of A, N, E. So meaning, this we have a suffix, meth, meaning an alkane with 1 carbon will be called methane. This one will be called ethane. This one will be called propane. This one will be called butane. This one will be called pentane. We are adding A, N, E. A continuation. The one with 6 will be called hexane. The one with 7 it will be called heptane. You can continue. Go on. Yes. So you're going to have all those results. And that's how you find the number of carbons. So if you are told how many carbon atoms are in ethane, there are 2. Because of eth. So there are 2. And how do you know that it is an alkane? There is A, N, E. If it is alkene, it is E, N, E. That's a different issue also. So in this case, These are alkanes. Okay. Now that we know how to find the number of carbon atoms, we can go to finding the structure, the molecular and the structure, the molecular formula, the structure formula. Then we can go to skeletal structure. I want you to be familiar with all that. All right. So here is a question. Here is a question. And the question says, what is find the molecular structure and skeletal formula for A, propane, B, and decane. We want to find the molecular, the structure, and the skeletal. Okay? So we want to find those structures. How do you draw? How do you come about those structures? So we'll start with the molecule. Molecular, we use the formula. So CN H2N plus 2. Now, what is the value for N in propane? Since it is prop, okay? Prop, meaning it is 3. Remember the suffix that we discussed in this first discussion? We said prop, it is 3. Okay? And AN, meaning it is an alkane. So, whenever you have a compound, a name, for example, this name, what is the first thing that you need to do? ANE means it is an alkane, meaning the formula for alkanes is this one. They all have different formulas. Alkanes, alkenes, alkynes, alcohols, acids, they have different formulas. So, then this one will help us to know how many carbons are there. So it is 3, and the formula is there. So what we're going to do now is substitute this 3 into the N. So we have Cn, which is C3, 2 and 3 plus 2. So meaning it will be C3H, 2 times 3, it is 6. 6 plus 2, it is 8. And this is the molecular formula. How about the structure formula? Structure formula. So the structure will be, you get the 3 carbons. By the way, carbon is bonded, has 4 bonds. Carbon is surrounded by 4 bonds to obey the octet rule. So we have carbon, carbon, carbon. How many bonds are we having here? It's 1. So we can still add 2, 3, 4. 4 bonds. This one has 1, 2, meaning remaining 3, 4. This one 1, 2, 3, 4. How many hydrogens are we having? 8. Distribute them. 1, 2, 3, 4, 5, 6, 7, 8. This is the structure. Okay? What is remaining now? It is the skeletal. How do you come about the skeletal? Okay? Having what we've done here, the skeletal will only show carbon. So that's it. So how many carbons are you having? 1, 2, 3. So if you do this one, if you do this, if you say 1, there are how many carbons here? 1 and 2. Again, you make a corner. So there are 1, 2, 3. This alone, it is propane. It is just the skeletal structure. If you want, it can be like this. Anyhow, it is still propane. And that is correct. We'll go to the next question. The next question is B, and decane. alkane, the formula, because we have A and E, just by seeing this, just connect that the formula is CnH2n plus 2. Because alkanes ends have a suffix, a prefix of A and E. And the formula for alkanes is this one. How many carbons are in this alkane? Whenever you see alkane, you go back to the drawing board. Okay, you go back to the drawing board, you check where we're writing things. Alkane, it's just here. And it has 11 carbon. So this simply means we are going to have 11 carbons. So it will be C11H11 plus 2. Now, what will be the answer? What will be the final answer? The final answer will be C11H 2 times 11, 22 plus 2, 24. And this is the molecular formula. Just like that. It's simple as that. What is next now? The next thing we'll do here, it is to come up with the structure formula. Okay, so how will be the structure formula for this? It will be C up to 11, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then you start putting hydrogen, putting hydrogen, you write it properly, then you distribute the hydrogens. And if you count the hydrogens that are there, they should be 24. They should be 24. The structure may change that's when we connect to isomerism. It can change. We'll come to that later. So 1, 2, 3, if you count them, they're 24. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Even here 11, which is 22 plus 2, 24. What is remaining? The skeletal structure. Try to draw a skeletal structure. Pause the video, draw a skeletal structure, then you come back to the drawing board. So what do? You can start from here. You can either start it from like this, or you can start it like this. So you can say 1, 2, 3, 4, 5, 6, 7. Let us counter check. How many carbons are we having? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this is the skeletal structure for alkane. Correct? Okay. Now that we now continue with the naming of alkanes. There are simple rules that are followed in naming that will make your work easy whenever you're given a question. You're told to name an alkane. For example, you have a question, you're being given a question that give UPAC name to the following structure. And the structure is CH3, CH, here there is CH3, CH, 2CH, 2CH3, then here maybe we can put something like CH, 2CH3. Alright. Want to look at the rules while it's comparing what we have. The question says give the UPAC name. UPAC name for this structure. So, what do we have? What are the steps that we need to follow to name this compound? The first step is to find, I'll read the steps to you. Let me just give you the steps and then we start following bit by bit. The first step is to find the longest hydrocarbon chain as your parent chain. So the first step is to find the parent chain, the longest. Note that you can make as many corners as possible. You may have to 10 corners to find the long chain. What do they mean? This compound you're having, you need to find the longest chain. So you can count 1, 2, 3, 4, 5, 6. How about 1, 2, 3, 4, 5, 6? We are counting the carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Still, the longest chain remains 6. So you can either start from this side going the chain, or you can start from this side going the chain, whatever. The next thing, number the carbon atoms in the longest chain starting from the end near a functional group or near the first branching point. After identifying which one is the longest chain, in this case we will identify this one 1, 2, 3, 4, 5, 6. We have this as the longest chain. Then now we can number 1, 2, 3, 4, 5 up to 6 from this longest chain which we're having. Now, where do you start from numbering? It is very important. Where do you start from numbering? You start from the one. The first number should be, where you start numbering should have, near it should have a functional group or a side chain. What is a side chain? These which are attached to the longest chain. So if you look at this carbon, this is, if we start from here, 1, 2, meaning here we found the side chain at carbon number 2. How about starting from this side? 1, 2, 3, 4, meaning the first side chain is on carbon number 4. So which one do you give preference? We give this side which finds the first side chain earlier than the other. So when numbering, you start from 1, 2. So we're going to start from this side going that side, because the first side chain is on number 2 this side, but the first side chain is on number 4 when you start from this side. So we can number 1, 2, 3, 4, 5, 6. After numbering, you identify and number the substituents groups using locants or numbers. We identify substituents. So by the way, we came up with the parent name. And the parent, the longest name, the longest chain, it has 6 carbons, meaning any alkane with 6 carbons. If you remember very well when we started naming them. So how do we call an alkane with 6 carbons? It is hexane. So meaning the parent name is hexane. Then side chain. What are the side chains we're having? This is the row number 3. We have this one. How do you call this compound? This organic compound? It is methane. But when it is a side chain, it will be methyl. When it is a side chain, it will be methyl instead of methane. So we have 2 methyl. Why am I saying 2 methyl? Because it is on the second locant, second carbon in the longest chain. What other side chain are we having? Ethane. Where am I finding those names? I'm finding them from what we did in the first place. Whenever you see an alkane with 2 carbons, it is called ethane. Whenever I see an alkane with 1 carbon, it is methane. So this has 2 carbons, so meaning it is ethane. Now, since it is a side chain, it will be ethyl. It is on which locant? 3. So it is ethyl. Okay? If it was propane, it was going to be propyl. Butane, butyl. Pentane, pentyl. Hectyl. Heptyl. Octyl. Nonyl. Decyl. Okay? Just like that. So we have these side chains. What is the next rule? Rule number 4. Use di, tri, tetra. Okay? Use di, tri, tetra for a same side chain. What's the meaning of this? For a similar side chain. What does it mean? So what it means is, if in a long chain we are having methane here, methyl, and we also have methyl here, and we also have another methyl, how are we going to locate them? Meaning, you're going to say, if you had on the locant 2, you put 2. If you had on the locant 3, you put 3. If you had on the locant 4, you put 4. Now, if there is 1, it will be methyl. If there are 2, it will be dimethyl. If there are 3, like in this case, it will be trimethyl. If there are 4, it will be tetramethyl. If there are 5, it will be pentamethyl. You continue just like that. So that's what it means, the rule number 4. Rule number 5, write the name as one word. Write the name as one word. So let's just write the name as one word. So before we go to writing the name, when writing the name as one word, we need to observe one thing. We need to observe alphabet. You start with the name with the first alphabet, with the first letter in the alphabet. So this one is a parent name, it will automatically be the last thing to write. Now between meth and eth, which one comes first in the alphabet? It is eth. So it will be, the name will collectively be 3-ethyl. What comes next? This one now. 2-ethyl, 2-methyl, now that we are done with the side chain, parent name. 2-ethyl, 3-ethyl, 2-methyl, hexane. And that is the answer. 2-ethyl, 2-methyl, hexane. Just like that. Let us go to another example. The next example, we use a skeletal structure. What if we are given this? How do you name this structure? How do you name it? We start, let us follow the steps. So, collectively, or in summary, the steps are 6. You find the longest chain, you number the carbon atoms in the longest chain, you identify and number the side chains, and put locants. To those side chains, you use di, tri, tetra for same side chains. Then you write the name collectively following the alphabetical order. But the parent name should be the last name. So we start. What is the parent name for this? Meaning we are going to identify the longest chain. How are we going to identify? Let us start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 1, 2, 3, 4, 5, 6, 7, 8, 9. Anyhow. So we choose this one. If you want, okay, this time let's use the different one. We're going to choose this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the longest chain, it is, since there's no double bond, it is saturated, meaning it is an alkane. An alkane with 9, it is called nonene. Okay. What next? We put numbers. How are we going to put numbers? Since it is 1, 2, 3, 4, 5, 6, 7, 8, 9, or 1, 2, 3, 4, 5, 6, 7, 8, 9, where are we going to start from counting? We start where there is a side chain nearby. So meaning we have this as a side chain, which is not part of the long chain. Because long chain, you can't count as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. You go just one direction. Not just one direction, but you head in the same position. You can't count there, then you jump, you skip to this. No. So now, this is a side chain, and it is near this carbon. So we'll start counting from here. Meaning this is 1, 2, 3, 4, 5, 6, 7, 8, 9. In that order. The next thing now, here it is to identify the side chains. Side chain. What side chain are we having? It is being branched from this carbon. And it is here. There's only one carbon. How do you call an alkane with one carbon? It is methane. Since it is a side chain, it will be methyl. It is on which number? Carbon 2. So 2 methyl. Okay. Do we have any side chain? No. So what is the name collectively now? Since we don't have many side chains, we just get it direct, following alphabet. Okay? We don't follow alphabet in the parent name. The parent name will always be the last one. So this will be 2-methyl nonene. 2-methyl nonene. As simple as that. We'll quickly go to the next question. So the next question is, we have this one, which is, okay, we have this one. This should be 3. Then you can put 2, 3. You can put 2 here. It's 2. The bond is on carbon, by the way. 3. Okay. And here you can put this. Okay. We have this. So what are we going to do even here? What are we going to do? The first thing, it is the parent name. You can pause the video if you want. Try to answer this question and you do the counter check. What is the parent name for this? Parent name. So let us identify the longest chain. How do we identify? We're going to count 1, 2, 3, 4. It is not the longest chain. 1, 2, 3, 4. Not longest chain. 1, 2, 3, 4, 5, 6. Is it? 1, 2, 3, 4, 5. We have 5. Okay. Which one is the longest chain now here? 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6, 7. Interesting. Interesting. So you can count 1, 2, 3, 4, 5, 6, 7. And that is the longest chain. Good. Maybe there's another longest chain apart from this one. 1, 2, 3, 4, 5, 6. No. So it is 1, 2, 3, 4, 5, 6, 7. Okay. So meaning it is heptane. Heptane. That is the parent name. How will be the locations? The locants. The locants. If we start from this end, 1, 2, 3, the first side chain is on 3. How about this end? 1, 2, 3, it is also on 3. Okay. The other side chain is on 4, even it's on 4. So you can start from either any of the sides. So you can say 1, 2, 3, 4, 5, 6, 7. Okay, that is the same thing. So side chains now. We got the side chains. Side chains. How many side chains are we having? We have this as a side chain. We have this as a side chain. We also have this as a side chain. And they're the same. It's the same organic compound. This is methyl, this is methyl, this is methyl. So we won't write them separately, no. Instead, what we're going to do, the first methyl is on 3. We're going to put 3, comma. The second methyl is on what? 4. The other one is on what? The 5th carbon. Now that there are 3, are we going to call them methyl? No, they will be trimethyl. So we're going to write trimethyl. Good. What other thing are we going to do here? Now we're going to write the full name for this. So what are we going to say? We're going to say the name will be paper. Not paper, where to write the name. Okay. Meaning the name will be, we get the 3, 4, 5. So it will be 3, 4, 5 trimethyl. What is the parent name? Heptane. As simple as that. 3, 4, 5 trimethyl heptane. As simple as that. Okay, I'll now give you something to do, a task. Okay, so go and work out this one. Go and find the UPAC name for the following structure. The first structure is yeah, it is just like that. This is the first one. A, go and try that one. B, go and try this one. Just like that. 2 questions. Try to find those and come up with an answer. Maybe I give you answers. For this one, your answer should be, try to work it out, but your answer, let me pause the video so that I try to find, then I give you the answer here. Alright, so the answer for the first one, it should be 3 ethyl 4 1 methyl pro pure 2,2 dimethyl octane for A. Hope you're going to find this answer. Then for B, your answer, from the answer that I have found, it should be 2-chlorobutane. If you're failing to reach this, then there's a problem somewhere. Then you go through the video again so that you find the correct answer. For today, we end here. In the next video, we'll look at the properties of alkanes and some of the reactions of alkanes. Then we'll go to isomerism of alkanes. After that, we'll go to cycloalkanes, meaning we're done with alkanes. Then we'll go to alkenes. Bless up.